Yo, what's up, geometry students? We're going to just breeze through this homework because most of it is easier, and I'm going to spend some time on the harder questions. We learned about angles inside of polygons, how the sum of the interiors is just adding up the amount of triangles you have. You will always have two less triangles than the amount of sides. You can see we have two triangles here, which is why all of these add up to 316. You get 116 if you subtract all the other ones out. This being 1, 2, 3, 4, 5, 6, 7. 7 sides turns into 1, 2, 3, 4, 5 triangles. So you have 180 times 5 gives you the total amount. And then you go ahead and subtract and you get the 94. If you want to figure out if we have a regular, it means all of the sides and angles are the same measurement. We have a 10-sided polygon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, you have 180 times 8, and we'll divide that into 10, and you get that each angle has to be 144. If each angle is 144, boom, you'll find that the specific one is 14. Okay? Then we talk about exterior angles. Exterior angles, this is when things get a little bit more complicated, are the angles that create 180s with the interior. So here's an interior angle. Here'd be the exterior angle. What we find is that the exterior angles are actually equal to the central angles if your polygon is regular. So what's great about central angles and exterior angles? They have to add up to equal 360. All of them. You got 5 exteriors, that'll add up to 360. And that's the other thing that we talk about, that the sum of your exteriors is 360. Not 360 times n, not anything, just 360. And that'll be the sum of these central angles. So 360 divided by 5 will be your central angles. Which are 72. If this is 72, that means this is 72. Watch this. If you know the exterior angle, now you know the interior angle without having to do that much extra work. For example, you could have just done 180 minus 72. And boom, you got 108. That must be each interior. Or you could have said, well, I'll have 3 triangles and I'm going to split that evenly into 5 angles. So you could have done 180 times 3 to get that the total sum is 540, and then divide that evenly amongst the 5, and you get that 108 as well. What's going to be very important for next lesson when we find the area of this is that we could split these 108s in half, and we know that this exterior is the same as the center. We can realize we have a bunch of congruent isosceles triangles all around. To find the area of the entire shape, we're just going to split it into triangles. So we see we have isosceles triangles because we have 2 of the same base angles. All right, now we understand this is 180 because we have 7, 1080 because we have 7 180s. Next question is like, what if we have an angle measurement? How can you find the number of sides? Well, it's like if every exterior angle is 36 and they're regular, so they're all 36, well, the amount of sides times 36 has to add up to equal 360. This is the sum of our exterior angles. So 36, how many times is 360? We end up just having to divide. We get n is 10. Very easy. Then we go to question 5, and we realize it's going to be easier to work with exterior angles than interior. If the interior is 120, then the exterior of all of my angles has to equal 60. Well, how many 60s go into 360? Oh, it's got to be 6. This is a lot easier than saying, oh, how many 120s go into this total amount of interior angles. Like this is a harder thing to do. You can do it. It ends up being the same exact equation, but you have to distribute. And you have to realize it's, oh, how many 60s go into 360? Same question. 6 is the same, easy. 7 is the same, is easy. This adds up to equal 360. Since we have a nonagon, we have 7 180s is the sum. So we'll have 2x plus the sum of all those angles. You'll solve for x here. All of these angles add up to equal 360. So boom. And then we get to our two questions, which are the hard questions because we're going to start getting you ready for Algebra 2. And here is the question. If I gave you this equation, do you know how to solve it? Hopefully you're saying yes. If I have that equation, I know how to solve it. I got x could equal -2 because 0 times -6 is 0, and x could equal 4 because 6 times 0 is 0. So that's an easy equation to solve. Cool. But now the question is, if I give you this equation, could you solve this equation? Well, the key is that they're the same. How do you know that they're the same? Because I know what this is distributed. It's x squared plus minus 4x's plus 2x's minus 8. I distribute everything and I realize I get x squared minus 2x minus 8. And we realize that this is the same as that. This is how we solve a lot of quadratic equations. We turn it into a factored form to be able to solve. Now, what's the key to quadratics? That if you have an x plus a times an x plus a b, after distributing everything, you get x squared plus the a plus b x's plus the a times b. Again, you have x squared plus ax's plus bx's plus a times b, and that means you have a plus bx's. Well, we will take quadratics, we will turn them into factored binomials so that we can solve. How do you do that? You find the two numbers that add to get the middle and multiply to get the last. This is not a great example. I usually use x squared plus 5x plus 6. I like this better. Well, x plus some number times x plus another number will equal x squared plus 5x plus 6. What are those two numbers? It's the two numbers that add to get to 5 and multiply to get to 6. Those are 2 and 3. Now, if you double checked and you distributed, like I'm going backwards, I'd have x squared, I have 2x's, I'd have 3x's, I'd have 6. Yeah, I got that. Now we get the solutions are -2 and -3. Okay, so distributing, factoring go hand in hand. If you understand how to distribute two things to two things, you should understand how to factor two things to two things. Many of you use this x. I don't like the x. I don't think it makes any sense mathematically. So we'll just leave it at that. We got a width and a length that is 12 more than twice the width, and the area is 320. Well, our length times our width has to equal 320. How do I solve this? Well, we end up with 2x squared plus 12x's equal 320 after distributing. But here's the key, guys. When you have x squareds and x's, you can't just isolate the x and get the x by itself. Not allowed to do that. You can't do that. Instead, we have a quadratic. To solve quadratics, we can either factor or use the quadratic formula. Now, how do we do that? Well, we're going to have the equation set equal to 0. So I'm going to subtract the 320 from both sides. I'm going to actually divide everything by 2, or you could factor out the 2, or divide everything by 2. If you divide everything by 2, the 2's gone. And then you realize, okay, I can't get the x's by myself because I have x squareds and x's, different kind of x's. So what do I have to do? I have to try to turn this quadratic into this factored form. X plus a number times x plus another number equals x squared plus 6x minus 160. You have to find the two numbers that will add to get 6 and multiply to get 160, negative 160. The two numbers are 16 and negative 10. If you distributed this out, you get x squared, you get 16x, you get negative 10x, and you get negative 160. Boom, we get that. Giving us our solutions are negative 16 and positive 10. Well, I don't want a side length of negative 16, so I'm not going to include that one. I'm just going to include that. The next question is a great question because it involves you understanding distribution and factoring all at once. So we have a garden that is a 5x4, and we're going to increase it by the same amount until our area is 56. Well, that means that our length times the width has to equal this 56. How do we solve this? Well, we're going to have to get everything on the one side. We're going to have to try to factor and solve. I'm going to distribute. I get x squared. I get 4x's. I get 5x's. I get 20. Oh, yeah. The 4x's and the 5x's are just 9x's. Oh, this makes sense. I could go backwards from this to this because I know 4 plus 5 is 9 and 4 times 5 is 20. That's not what we're going to do here because I'm going to subtract the 56 and get a minus 36 here. Now we have something new. What two numbers placed into this when distributed would give us this? Well, the two numbers add to get 9 and multiply to get 36. You thinking about 36, like 6 and 6 doesn't work. You're thinking 9 and 4 doesn't work. You're thinking 12 and negative 3, that works. And now this is an easy thing to solve because negative 12 makes this 0, positive 3 makes this 0. We will be practicing a lot of algebra throughout the rest of the semester because this is stuff you will see a lot of in Algebra 2. All right, peace.